Okay, good afternoon, everyone. Welcome to this talk, Stream Processing Solutions for the Enterprise. My name is Jin from Ververica. Stream processing technologies has been around for decades. Nowadays, as you know, Apache Flink is a de facto standard for stream processing, and is being used by many enterprises. We, as Ververica, has been working on providing Apache Flink-based solutions for the enterprise for almost 6 years. This talk, I will present our experiences in this journey, and I will show you the solutions we have built for the enterprise. The talk is organized as follows. I will start with a few words about our company and myself. Then I will present the solutions we have built for enterprise from 4 different angles: simplicity, efficiency, flexibility, and security. And afterwards, I will show an overview of Ververica Platform, and then summarize the talk at the end. Our company, formerly known as Data Artisan, was founded in 2014 by a few PhD students, graduate students from Technical University of Berlin. We created Apache Flink at that time and donated to Apache Flink, Apache Software Foundation. And in 2016, Apache Flink 1.0 was released. Right after 1 year, in 2017, we released the first commercial off-the-shelf product called the DA platform. In 2019, we were acquired by Alibaba, so the product was also renamed to Ververica Platform. And today, with a 6-year proven history, our product has become a mature platform and provide great features that are part of the solution for many enterprises all over the world. I was lucky enough to join the journey 4 years ago and learned and contributed to Flink, and now I manage a team. We provide technical solutions for our prospects and customers. Flink Forward, similar like current Flink Forward is Apache Flink conference. We are the official organizer. We organized the first one in 2015 in Berlin. And this year, we will have Flink Forward in Seattle in November. I hope to see some of you there. OK, now let's have a look at a few solutions we have built to make things simpler. Imagine you created a Flink job and deployed it in production, and then the input traffic is increased. So you want to scale up the job by stop the job with a save point and restart the job from that save point with a higher parallelism. Maybe after some time later, you discover a bug, then you want to fix that bug with another stateful upgrade. During this process, you actually created 3 different Flink jobs. Each time you have to tell Apache Flink from which state the job should resume from. However, from business point of view, this is one single business application. The state should be carried over automatically. So in Ververica Platform, we provide a higher level abstraction and let user manage applications instead of jobs. So the latest state, be it a checkpoint or user manually created a save point, is automatically carried over for users. We use a deployment to represent a business application. All the historical jobs are linked to this deployment. And in the deployment, you can see the history of all the state snapshots, include the checkpoint and save point, and also which state will be used for the next job of this deployment. With this solution, managed Flink jobs become much easier, and a team who can only manage 15 applications before using our solution can now easily manage 300 applications with our solution without adding any additional team members. Advanced SQL Editor is another solution that we built to make Flink SQL development simpler. You know, Flink SQL client is a command line based tool. It is a bit hard to use. In-memory catalog is lost when you exit from the session. So in contrast, Ververica Platform provide a web UI-based SQL editor with auto-completion. It can even deduce the table DDL, depends on the context you are in that SQL editor. It can validate your SQL statement by checking the syntax and also the existence of tables, views, UDFs. You can quickly preview the result of your SQL statement in a session cluster instead of creating a job cluster every time. Ververica Platform manage your connectors, formats, and the UDFs. If you need a customer one, you can just upload your jar onto the platform. The editor has a built-in persistent catalog integrated out of the box. And to use a customer, with a bit of configuration, you can have JDBC, Hive, and CDC catalog as well. Also, the changes to the SQL deployments are version controlled, so you can always check the difference between two versions and fall back to previous one if needed. With the third solution, we try to make it simpler for you to automate your Flink job deployment. When managing many Flink jobs, it's crucial to have automation and traceability in place, especially in production environment. You want to reduce manual actions as much as possible. You want to know what changed at when. So to support this, on top of our existing web UI and the REST API, we implemented a Kubernetes operator. So with Kubernetes operator, you can specify your Flink deployment in a manifest YAML file. Then you can give it to deploy your job into Kubernetes natively with kubectl. If you store the manifest file in the Git repo, then together with your CD system like Argo CD, Flux CD, then you can manage your Flink jobs in a GitOps way. All types of deployments in Ververica Platform can be managed by the Kubernetes operator, be it streaming jobs or batch jobs, whether it's jar-based deployments or Flink SQL or PyFlink deployments. Also, our Kubernetes operator is integrated with our web UI. That means you can manage the same deployment from both sides. And with web UI, you always have an overview of all the deployment you are managing. Yeah. Troubleshooting failures and exceptions by looking at the Flink jobs logs and metrics can be time-consuming. So Smart Advisor is the fourth solution. We try to simplify and speed up the troubleshooting process for our customers. Our Smart Advisor consists of a dynamic knowledge base that is built on top of our multi-year experience in operation and support, and also a process to collect, transform, aggregate logs, then update our knowledge base after they are analyzed and annotated by our engineer expert, and also the process to collect diagnose feedbacks. Obviously, some UI components to show the diagnosed result. The advisor can support diagnose failures and exceptions during that is appearing in development and also the operation phase. It can analyze potential risks of running jobs, and in some cases, the proposed solution can be applied with a single button click. The screenshot shown on this slide is an example where the task executor was shut down, and the advisor explains the reason of this exception, and followed by two possible solutions. And users can click helpful or unhelpful to give us feedbacks. Not only we want to make things simpler, but we also want to our customer run Flink jobs efficient. So the first solution we built here is a faster, stronger Flink. As we know, Flink is a stateful stream processing engine. The performance of its state backend plays a very important role here. We've deep dived into the core of Flink and have implemented a powerful state backend that is specifically tailored for stream processing, namely Gemini. Although Gemini has many advantages, for the sake of time, I mainly present a few of them. First, Gemini state backend uses a tailored state store that consists of memory and disk. What it differs from RocksDB state backend is that the state in the memory can be snapshotted directly to checkpoint storage without first being flashed to disk upon checkpointing. This this significantly reduces the checkpoint sync time and also the CPU and disk I/O that is required for flashing and compaction. In addition, when doing checkpointing, all the operators are doing it at the same time. So this effectively avoided the sudden CPU and I/O burst, which may impact the stability if you are using RocksDB. Second, Gemini state backend uses tiered storage. So it tries to keep the hot state in memory and push the warm state to local disk, and the cold state will be evicted to object store. Because most of the lookups are point lookups, that's why we use a hash index in memory to speed up those point lookups. And sorted index, we use sorted index for the state in local disk. With that, we can reduce the disk, the state compression ratio, or increase the state compression ratio, and reduce the state size. And the other advantage with this design is that your state size really have no limit here, not even limited by the size of your local disk. This is very important when in the cloud environment where local disk capacity are often limited. Third, when you join multiple streams based on the keys, values are not needed unless there is a successful join. So Gemini state backend can automatically separate keys and values such that we can have more keys in memory to check for the joining. And storing the values outside of LSM data structure can avoid the disk I/O overhead required for compaction. Last but not least, when you resume a Flink job from a state, Gemini state backend can start processing incoming traffic immediately after the state metadata file is loaded. So this can, the rest of data can be loaded lazily when it's needed. This can reduce the job downtime up to 90%, especially when you are resuming from a very large state. The second solution to improve the efficiency of autopilot, streaming job normally run for weeks, days, or weeks, months, or years. However, the incoming traffic or the workload rarely remain the same all the time. For example, stock transaction happens only during the daytime, and there should be less ride traffic during the nighttime, or maybe some topics suddenly become hot on X or Twitter. Our autopilot works with Flink 1.11 and later. It monitors Flink job operator metrics continuously and use a sophisticated algorithm to calculate the target parallelism, then do a scale up and scale down accordingly. You can set the autopilot into monitoring only mode, and then if you feel confident, you can activate the feature. You can also set the cooldown time to avoid too frequent scale up and down, and you can limit the maximum job parallelism to it can scale up to avoid high cost. Okay, now let's switch the gear a little bit to flexibility. We have many customers. Some want to start up quicker avoid high upfront investment like Kubernetes infrastructure. Some want to focus on business logic and avoid operation overhead. Some process very sensitive data. They want to have a full control where and how the data are processed. Metadata of these Flink jobs may or may not be sensitive. To meet those requirements, we provide our solution as a software which you can download, install in your data center or private cloud. We also offer our manager solution where the control plane runs in our cloud and the data plane runs in our cloud, or you bring your own cloud. In terms of language support, we offer the support for all languages which are supported by Apache Flink. Whether you are early adopters, has many jobs from DataStream API, or you are the Flink SQL user, you want to move every user case to Flink SQL, or you only have Python expertise in-house, and there is always a place for you in our solution. Generally, we cannot talk about enterprise solution without talk about security. So in Apache Flink, you can manually configure internal, external connectivity based on SSL. And this can be tedious or time-consuming, yet it has to be done carefully and correctly. Our platform provide one-click SSL setup at the job level. At platform level, you have the few full-fledged security suite, authentication, authorization, and multi-tenancy. This is especially useful for the large enterprise, which use Flink for many projects in many teams. Although the desired access are protected, undesired access may be done through a vulnerable software component. So we are also scanning, fixing security vulnerability regularly, and release our software monthly. In addition, audit log can help you to find out who did what and when, in case something happened. Having talked about all the solutions, here's an overview of Ververica Platform. It runs on top of Kubernetes. If the core is Flink runtime, so if your job runs on Apache Flink, they run on Ververica Platform as well. On top of that, Ververica Platform provides features that help SQL developer and data engineer to develop their Flink applications, and the DevOps, GitOps team to deploy their Flink jobs, and IT infrastructure to set up and configure your Flink deployment in a secure environment. As mentioned in the flexibility part, we run where you run, either on the cloud from major cloud providers or on your private cloud running OpenShift or vanilla Kubernetes. Here's a list of many features that are provided by Apache Flink. Apart from the one I mentioned before, we also have Flink job configuration, metadata management, artifact management, Jupyter integration. All these things make your life working with Flink even easier. And you can, within the same platform, you can also work with multiple Flink versions at the same time. So this will simplify your job upgrade process as well. With Kubernetes HA, you can save the operation overhead and cost of maintaining a separate Zookeeper cluster. Needless to say, we provide long-term support with SLA. Okay, to summarize, we have been working on providing stream processing solutions for the enterprise since 2017 for 6 years. So let user manage applications instead of jobs. Advanced SQL editor, Kubernetes operator, smart advisor makes things simpler. And with our fast and stronger Flink and autopilot feature, you can be more efficient. And also we run where you run, and we support all the languages which are supported by Apache Flink. Last but not least, we want to make sure your data and your Flink job are protected with a comprehensive security solution. Okay, that's it for my talk. I don't know whether there's any question.